This is Jake. I'm sorry, we missed the very beginning of your question. Could you maybe restate it, please?
Ahora sí. Evidentemente, bueno, no teníamos el directo activado, pensamos que estábamos saliendo al aire. La NASA acaba de confirmar de que con el sistema SOFIA pudieron confirmar efectivamente que hay agua en la Luna. El sistema SOFIA es un telescopio de observación estratosférico, es un telescopio infrarrojo que va montado arriba de ese avión, de ese Boeing 747, tal cual como vemos en las imágenes. Tiene una puerta que se abre y el telescopio queda para hacer observaciones espaciales. Ese telescopio, como recién confirmaron, y lamento no haberlo puesto al aire, es que lo utilizan generalmente para observaciones muchísimo más lejanas que la Luna. Pero bueno, viendo la necesidad de que una transmisión que conseguir agua, confirmar que hay agua en la Luna es importantísimo. Bueno, dirigieron ese telescopio y pudieron confirmar de que a nivel de superficie hay agua. Las interrogantes que tienen ahora es saber si efectivamente el agua esa, qué cantidad es, qué tantos recursos pueden tener y cómo se forma el agua. Sobre todo eso es muy importante para ellos. Lucas, ¿qué tal? Buenas tardes, gracias por sumarte, gracias a todos los que están allí. Escuchemos lo que están diciendo. Pensé que esta transmisión iba a ser con video también, pero no, están transmitiendo solo imágenes.
Another example would be the near infrared volatile spectrometer, or NIRVIS. NIRVIS will measure surface and subsurface hydration, carbon dioxide, methane, all resources that could potentially be mined from the moon and used.
A tu pregunta, Pablo, que nos pregunta de en qué parte está, si está en toda la Luna. Aparentemente, si ellos decían de que ya tenían confirmaciones de que en determinados cráteres de la Luna, en lugares oscuros, había presencia de agua. Pero ahora aparentemente pueden confirmar de que, o sea, extraer agua de un cráter o de la profundidad en la Luna es extremadamente difícil y requiere muchísima energía. Si encuentran ahora, confirman de que hay en muchos lugares de la Luna hay agua que es fácilmente accesible, eso cambia todas las perspectivas de las misiones espaciales. Obviamente, si no tenemos que empacar y llevar agua hacia allá para poder mantenernos vivos, cambia las perspectivas de poder llevar mayor experimentos, mayor carga de pago, mayor combustible, en fin. Omar Reyes pregunta si este descubrimiento viene a reforzar el proyecto de realizar una base en la Luna. Sí, por supuesto. El descubrimiento de que haya agua en la Luna y que sea mucho más accesible de lo que ya pensaban es importantísimo, ¿no? Seguramente esta noticia que acaba de revelar en este momento la NASA, esta noche va a recorrer todos los informativos del mundo. Hay un panel en la NASA con esta conferencia de dos científicos de la misión, dos personas importantes del proyecto científico SOFIA también, y alguien del directorado de la NASA. A la pregunta de Fairway, dice, ¿son moléculas de agua lo que se encontró? El tema es así. El observatorio SOFIA tiene la capacidad de discernir perfectamente a nivel molecular cualquier partícula. Entonces lo sintonizaron específicamente para que si había dos moléculas de hidrógeno y una de oxígeno, que es el agua, lo detectara. Y tuvieron una detección positiva, o sea que es afirmativa la respuesta de que hay agua.
Down to about 75 degrees in latitude on the moon. So we only covered a few degrees on the moon. What also the abundance of...
Dice que con la observación que hicieron solo cubrieron unos pequeños grados de inclinación en la Luna, o sea, en una pequeña latitud.
Incorporated into these glass beads, so they're not in a form of ice or liquid.
La observación que hicieron fue de las moléculas. No pueden saber si eso es líquido o en forma gaseosa o cualquier otra.
We have David Curley from the Discovery Channel.
Discovery Channel está preguntando algo ahora.
Thanks for taking the question. You kind of touched on it there. I mean, this is an amazing discovery, but how much is there? Will it matter? Will it provide for astronauts if we need to mine it? Thank you.
Dice que es increíble este descubrimiento, pero ¿qué significa desde el punto de vista de la misión espacial para los astronautas?
Casey, I think maybe you could reiterate the amount of water.
Yeah, so the amount of water is roughly equivalent to a 12-ounce bottle of water within a cubic meter of lunar soil. But this, instead of being at a volume, this is spread across the surface of the moon. Whether or not it's usable for mining, I will turn over to Jacob.
Yeah, thanks, Casey. And this is this is the core part to the question, right? And I think several of us hinted at this, is that we really need to understand more about the water that's present.
Bueno, dice que tienen que entender mucho más sobre en qué formas está para poder saber qué tanta cantidad hay.
It's this complement of approaches, of measurements that we can make. Some of them look at just at the surface. Some can look deeper below the surface. Some see water in different forms than in other forms. We need to gain that broad picture of what the resource stock really is at the South Polar region. We also need to understand how we can not only approach it as a resource, but how we can also use it as a science resource.
Tienen que estudiar, dice, cómo utilizar esos recursos y necesitan obviamente mucho más información para eso. Y de esa manera pueden saber cómo está evolucionando el sistema solar, cómo evoluciona la Luna y el Sol. Carlos Uriel dice, bueno, ¿cómo se resume? Se resume que descubrieron que efectivamente hay agua en la Luna, no solo en los cráteres. No sé si se escuchó porque justo estaba hablando Jacob Blecher de la NASA, que efectivamente confirmaron de que hay agua en la Luna. Ya sabían que había agua en los cráteres, en las partes oscuras de la Luna, pero poder minarlos, o sea, poder sacar el agua de allí, requería enormes esfuerzos y enorme cantidad de energía.
I believe we have Joey Roulette from Reuters.
Hey, question for Paul and Jacob.
Paul and Jacob está preguntando.
Kind of similar to what was asked before, but what will it take to know whether the water molecules can be turned into usable resources to support?
¿Cuánto les puede llevar saber si esas moléculas que dicen que hay de agua, transformarlos en recursos utilizables?
Do you think we'll know this from more remote observations, or will we have to rely on future, robots or probes on the ground on the moon? Thanks.
I can give my first shot at answering that question. We already listed off a handful of additional payloads that are planned to go to the lunar surface. I think it's critical that we combine remote observation, which can give us the broad context. So, observations from SOFIA, coupled with other observations that look more broadly at the moon, can tell us regionally where we see those signatures. But then we need to also get on the ground and sample. So we have, as I mentioned,
dice que una de las cosas importantes que necesitan justamente es tomar muestras de la superficie.
So for instance, we're sending the Prime 1 drill to help us understand better how to approach it when we get Viper there. That's a more capable vehicle. So, answering the question exactly when we'll know is difficult. What I can say is that from a in situ resource utilization perspective, we have multiple approaches to extracting the water, multiple activities that are underway. And as we learn more, we'll know better which of those to develop further so that we can follow that approach. And it may be that there's multiple approaches.
Bueno, dice que hay muchísimas aproximaciones.
We also, again, have to learn just simply going up to the water, are we going to be disruptive to it to the point that we then can't use it? So, each one of these lessons helps us learn better how to query the lunar environment, the lunar surface on our next step moving forward.
Bueno, dice que tienen que seguir
Thank you.
adelante
Next, we have Kenneth Chang
con
from
las
the New York Times.
investigaciones
Kenneth?
para poder saber más específicamente sobre el tema del agua, ¿no? Porque
Kenneth, are
evidentemente
you
lo
on?
que tienen es la confirmación de que hay moléculas.
Okay, before we go back to Kenneth, let's go ahead and take some Ask NASA questions. If you would like to ask a question using Twitter, please use the hashtag AskNASA. So, we have a question
Sí,
from Ian Parker.
la fotografía del avión la
asking,
estamos colocando
what
nosotros.
volume of water is found, and
Lo
does
que
it
nos
suggest
provee
life
la
may have
NASA
been
es lo que está
present on the
abajo a
moon
la derecha, que
previously?
es esa imagen de la Luna ahora con la
Sarah,
cabina
can you talk about that?
del 747 con
Sure.
pintado
We covered a
Sofía,
little bit
¿no?
about how much water is there. It's not a lot. And it's also water by itself is really not enough. There are other ingredients necessary for life. And the moon is, frankly, a really harsh place. The radiation environment, the lack of
Bueno,
an
dice
atmosphere.
que la Luna
There are lots of
justamente
reasons we can talk
es
about
un lugar
this,
muy
where
duro,
life is just
muy complejo por la
not,
radiación
a
que
thing that we think
recibe
could have ever been possible.
y que justamente saber del agua es importantísimo, ¿no?
Thank you. Let's try to jump back to the Q&A. Kenneth, are you available?
Yes, can you hear me now?
Una pregunta más.
Sorry about that. I just want to clarify a few things. In 2009, there was data from Chandrayaan-1 about water in the sunlit areas. Is this a confirmation of that, confirming that it's water and not hydroxyl, but otherwise similar? And was there a confirmation of water in the deep craters from the L-cross, or is there also that ambiguity between H2O and hydroxyl?
Hi, this is Casey. So I can take the first part of that. The observations from 2009 with M-Cube on the lunar surface were of the 3-micron band, which could not distinguish between hydroxyl and water molecules. What our detection today on the sunlit moon is saying is that at least part of what M-Cube detected is in the form of molecular water.
Bueno, dice que lo importante de este descubrimiento que están anunciando es que con las observaciones de Sofía pueden tener una confirmación positiva de que esas moléculas sí son de agua y no hay confusión con otras moléculas similares y que no podían llegar a discernir con otras observaciones anteriores. O sea, ahora sí hay confirmación de que hay moléculas de agua en la superficie lunar, no solo en los cráteres.
Yes, can you hear me okay?
Yes.
Okay, and it's Coquino, so it's an odd name. No worries.
Ángela Milena pregunta de qué se trata. Están confirmando de que con el sistema SOFIA, que es un observatorio de infrarrojos que va a bordo de un avión, como estamos viendo, han confirmado la presencia de moléculas de agua en la superficie lunar, no solo en los cráteres, sino en la superficie. O sea, no saben todavía qué cantidad hay y qué tan fácil es pasar la agua líquida, ¿no? Pero que es un descubrimiento muy importante que requiere muchas más observaciones, tanto desde el sistema SOFIA, que ya planificaron misiones, como con los próximos rovers que están pensando enviar a la Luna y obtener muestras para poder analizarlas, ¿no?
Continuing observations with SOFIA. With the current data, it's just a snapshot in time of one location at one time on the moon. So we need, in order to understand the mobility of water and if it's moving and how it's really stored, we need more observations of different lunar phases to really be able to get at that mobility problem.
Bueno, dice que para saber mucho más, para saber sobre esto más, dice que ya están planificando nuevas misiones de vuelos con Sofía a bordo de ese 747, o sea, estratosférico, y hacer mayores observaciones de la superficie lunar para saber esa agua que descubrieron, si es general, cómo es el movimiento, cómo es la creación y entender científicamente todo este tema.
In the science support room in the Mission Control Center during Apollo 17 when they were at Shorty Crater. And I will never forget the scenes in that room when they found orange soil, because everybody in the room believed that that meant water, and they were devastated, many of them, though they're scientists, when they discovered, well, maybe it wasn't. I'm wondering, could those be exactly the beads that you're talking about?
Hi, this is Casey. So those are actually different kinds of beads. Those are volcanic beads that were erupted during a volcanic process on the moon. The the glass beads that we're talking about are little beads that form when a micrometeorite impacts the moon and melts part of the lunar surface. It melts it and could either deliver the water or form water from pre-existing hydroxyl, which then cools to form a little, what we are calling little glass beads. So there's the ones that they found on Apollo and the ones that we're talking about here are different beads. We do think that the Apollo glass beads like Apollo found may concentrate water, and hopefully we can do observations of the Apollo 17 site to possibly detect water at that location with SOFIA.
And if I may cheat and ask a follow-up, I'm particularly interested in the instrument that you were using. It's my understanding that it was designed and built by the Andor Company in Belfast, in Northern Ireland. Is that correct?
Está preguntando sobre la procedencia del instrumento que usan para medir esto, si está hecho en Belfast, en el norte de Irlanda.
Are you talking about the instrument that made this discovery on SOFIA? No, that was made.
Yes, the CCD device. I understood it was built by
Está preguntando
Andor.
si el dispositivo CCB que utilizaron para detectar esto. Dice que no le van a dar, no pueden darle información específica sobre el proyecto.
Okay.
Thank you. We will take another question from the phone lines and then go back to Ask NASA questions and then jump back to the phone lines. Let's start with Jim Siegel from NASA Tech. Jim, can you hear us? Okay, while we try to get through with Jim, let's go ahead and try to answer a question from Ask NASA. Based on the data for the near side of the moon, have we any assumptions for the far side? Could we find the same abundance and the same process? Casey, can you cover this question?
Yeah, so we believe that on the far side of the moon, the abundances are probably going to be very similar to what we see on the near side of the moon. We obviously would need more observations to really be able to tell if there's locations that may be different, though.
Bueno, tienen que observar en otros lugares.
Will James Webb Space
Saludos, nos manda Giovanni Smiler, gracias.
Water detection on the moon.
Yeah, thanks, Felicia. Well, it is true that Webb has instruments which cover this 6-micron wavelength. However, Webb cannot look in the direction of the Earth, Moon, or Sun. Its tennis court-sized sun shield blocks all light and heat from those directions, which is how Webb maintains its very, very cold telescope surface. So, no, it cannot look at the moon.
Okay, great. Here's a question for Sarah from Rev D. With finding water on the surface of the moon, do we expect to find more water at deeper depths of the moon?
So that's a great question, and one that we need more data on, right? So this instrument can only see the very top surface of the moon. But if we assume that these are in, these glass beads we've been talking about, right, they'll get mixed in deeper and deeper into the soil over time, right, as you get more impacts coming in and create new ones. So they'll get buried down to depths of feet, meters even. And we do expect to find that in various places.
El instrumento dice que detecta lo que hay en la superficie. Entonces, bueno, necesitan hacer mayores observaciones para poder tener mayores datos, ¿no?
That water is and how well it gets mixed into deeper layers.
Thank you. We're going to take one more Ask NASA question and then go back to the phone lines to see if Jim Siegel is available. Here's a question for Jacob. Are there going to be robots sent to mine the H2O and further explore the extent of the water quality?
Yeah, so that would be one potential option for how we might do this. Again, I'll go back to the point that we still have a lot to learn about how we can interact with these deposits on the surface.
La pregunta de nuevo, ¿cómo pueden interactuar con esos depósitos de agua? Esta pregunta es la última pregunta esta.
An interesting aspect to this result is Casey discussed two possible mechanisms for creating this signature, and it may potentially be a little bit of both. So at some point we'll need to learn enough so we can start making decisions about, is it easier to invest in being able to survive the extremely cold environment and go into these shadowed regions, or will it be easier to access the type of water that SOFIA is detecting right now? And that might require different amounts of energy or needing to be able to manipulate large amounts of regolith in order to extract that water. I can certainly envision ways that robots might be beneficial in all of those, but all of these are technology investments that we have to think about. And so this is a really good example of how this isn't only the Science Mission Directorate and our human exploration folks, but our Space Technology Mission Directorate as well. We all have to work together as we collect data from the science approaches to understand what technologies we need to develop to getting
¿qué tal?
our
Buenas
astronauts
tardes.
and robotically operated assets to the surface to
Bueno,
get the job done.
lo que está diciendo Jacob, que es el jefe de operación científica de la misión y operación humana, Directorado de Operación Humana de la NASA, es que evidentemente tienen que integrar todas las misiones y todos los recursos que tienen para poder seguir adelante con
Okay, I got your question for
este
Jacob
hallazgo, ¿no?
Bleacher, since you seem to be the most senior person who might know how decisions will be made here. Up until now, the Artemis program has put forth this sort of persistent mantra about focusing human landings at the lunar South Pole due to the potential water resources. And Jim Bridenstine has said, yeah, we're going to land there the first time. Now that it seems that water is a more ubiquitous, pervasive resource, one would think that this polar focus might pivot. I know you've had a couple of days at most to look at this. Are you now reconsidering landing sites as a result of this discovery?
Está preguntando si con estos descubrimientos están reconsiderando los lugares de aterrizaje en la Luna para las próximas misiones, ¿no?
That's a good point that you bring up. I will note that in discussions we've had about Artemis and going to the South Polar region, right from the beginning of Vice President Pence.
Porque originalmente pensaban ir a la región polar sur.
Water is one of the resources and rationales for going to this location.
Una de los temas de ir a ese lugar, al Polo Sur, es por el agua.
Which is access to light for greater than 50% of the time.
Dice que también otro de los temas es que ahí tienen luz el 50% del tiempo.
Where they see the sunlight, and a nighttime where they do not see the sunlight. And if you can take advantage of locations, for instance, at the South Pole, I mentioned that there are places where we see no sunlight in some of these deep craters. Conversely, there are locations on top of high ridges or mountainous peaks where we can see sunlight for more than half the amount of time.
Bueno, hay lugares donde pueden ver más luz que en esos lugares propuestos. Dice que ahí tienen energía solar, evidentemente, y tiene muchas ventajas.
Inside the sunlight. So, you know, water is one resource on the lunar surface, and we're certainly learning more about it and where.
El agua es uno de los recursos que hay en la superficie lunar.
That we will most likely use there. So, right now, the discussions we have are still focused on the South Polar region.
Bueno, por ahora las discusiones que tienen están centradas en la región polar sur.
Sarah, this is from Van Applegate. Will this change plans for Viper landing areas?
Yeah, so not at all, right? So Viper
si esto cambia el lugar de aterrizaje del Viper.
Areas, but also to look in areas that are less shadowed, areas that get a little bit of sunlight where we think there might be water deeper, and also look in areas of full sunlight so that we can compare all of these different types of regions in the polar environment and really get at where the water is located. And so this is actually a perfect opportunity for Viper to follow up on these results and look at where the water is.
Great. Next we have Alexander Witz from Nature Magazine.
Viper, recordemos que Viper es una misión rover de la NASA.
Are any of the upcoming rovers or Artemis missions planned to go specifically to or near Clavius?
Viper está planificado para el 2022.
Yeah, I can speak for the Artemis missions themselves that involve astronauts. We don't have a final decision on the landing site yet.
Todavía no tienen una decisión final donde van a aterrizar el día que vayan los astronautas allá a la Luna.
To volatiles, there are additional science objectives from the Science Mission Directorate. that will be of interest to us. And so we need to find sites that balance that access to sunlight, the access to water, places that we can.
Dice que para definir el lugar donde van a aterrizar los astronautas con la misión Artemis en el año 2024, primero tienen que definir cuál es el acceso a los recursos que tienen, por ejemplo, al sol y al agua, ¿no? La luz solar es un recurso tremendamente valioso también en la Luna por la energía que pueden capturar.
Thank you. Next, we have Kesha Rogers from the Executive Intelligence Review.
Yes, hello, thank you, and thank you for taking my question. Okay, so one of my questions was asked, so I'll just ask the question on what impact will projects and instruments such as the Intuitive Machines Lunar Ice Drill be for helping to extract the water that we found from the moon for use of the Artemis 3 or for crewed missions?
¿Qué impacto puede tener esto, dice, en los instrumentos que van a mandar a la Luna, dice, para poder examinar y cómo extraer el agua de la Luna, ¿no? Y sobre todo basado en la ubicación del agua. Si los instrumentos le dicen que van a ser capaces de extraer agua de la Luna, ya lo dijeron, ya dijeron la respuesta a esta.
Well, this is Jake, and I'll go ahead and just jump in on this one, and if anyone else has anything to add, feel free. But absolutely, all the data that we collect every time we go to the moon becomes critical information for us to understand how we will conduct.
Cada vez que tienen nuevas informaciones de los datos de la Luna, dice, es crítico para las misiones.
Like the South Polar region where we have not been before, especially when you couple it with exciting observations from SOFIA that we're talking about today. Everything new that we learn is valuable in how we develop those operations. And I've already mentioned the collaborative work between our mission directorates to collect the science information and data, develop the technology, and make choices about what pathways.
Bueno, dice que evidentemente tienen que confirmar cómo es que está y poder desarrollar las tecnologías necesarias para poder usarla, ¿no?
So the drill data will absolutely be important to us in understanding, not only future missions, but we already talked about how it's of value to the next mission, Viper, that will follow up. So,
dice, obviamente dice que es importantísimo saber esto, pero no solo para todas las misiones de Artemis, sino para la próxima de Viper. Viper es una sonda, un robot, un rover que está planificado de llegar a la Luna en diciembre del 2022.
Next, we're going to take some Ask NASA questions. This is going to Katie. What was the original intention to observe moon using SOFIA?
Me río porque Mr. Abaco dice agua embotellada en la Luna.
I began studying lunar hydration, looking at the 3-micron band that couldn't distinguish between hydroxyl and molecular water. And I was always questioning my advisor, Paul Lucy, why is this such a hard problem? Why can't we distinguish between the two? That led us down a rabbit hole to look for another way to look for water. And it turned out that 6 microns has a unique spectral fingerprint that is specifically for water. And so we went and started looking at instruments that could potentially make these kinds of observations. We found that no spacecraft currently or in the past had the ability to measure the moon at 6 microns. And from the ground.
Están hablando sobre aspectos técnicos en la observación de SOFIA. Cómo es que lograron descubrir de que las moléculas son efectivamente de agua y no de otro compuesto similar que podría llegar a confundirse de acuerdo a la longitud de onda de la observación en los infrarrojos. No entendí la parte técnica.
We were awarded some director's discretionary time to test this observation, and it turned out to be pretty great.
Great, thank you. So this question should probably go to Casey, and maybe Sarah can follow up. This is from Dina. How can water exist on the moon without an atmosphere to protect it?
That's a great question. So I mentioned briefly that we believe the water is being stored inside these micrometeorite impact glasses, and these would shelter the water from being lost to space or migrating to the lunar poles. And this would mean that without a lunar atmosphere, the water could stay on the surface of the moon. Sarah, would you like to expand on that?
Yeah, that's basically the deal, right? Once you create these little glass beads in a very sort of hot, violent way.
Disculpa que no estoy escuchando en este momento, estoy tratando de sumar a Sergio, que es un físico espacial, a nuestro canal.
And so it is able to withstand the harsh conditions there at the moon.
Thank you. This question is to Paul. How does the discovery of water on the sunlit surface of the moon affect the focus of future NASA missions with respect to further probing the observation of more distant objects and planets, such as meteoroids and asteroids along with Mars?
Yeah, that's a great question, and I'm going to answer it by saying I don't think it's going to change it at all, because we've been focused on looking for water all over the solar system for quite a while. Our Mars strategy, how do we pick where our rovers and landers go on Mars?
¿Cómo modifica esto sobre las misiones a Marte? Me imagino que preguntó, bueno, no estaba escuchando, estaba tratando con el otro tema de sumar a ver si podemos sumar a Sergio. Y bueno, lo que sí él contestó es que no les cambia nada en el resto de las misiones espaciales, porque dice que ellos están continuamente observando y buscando a ver la posibilidad de agua en todo el sistema solar, obviamente.
We're building a satellite called Europa Clipper, which will be orbiting Jupiter and studying the moon Europa, which is known to have a subsurface ocean on Jupiter, which sometimes breaks through to the surface. So we'll be studying the surface as well as the interior of Europa. We're sending a quadricopter out to Saturn's moon Titan, which has a system, a hydrology system that's based on methane instead of water. And so looking for water all over the solar system is something we've been doing for quite a while, and we've learned that the moon fits right into that strategy.
Thank you. We're going to jump back to the phone lines. Let's talk to Chelsea Gold from space.com.
Hi, thank you so much for taking my question. This is Chelsea Gold of Space.com. I know we've covered this a little bit already, but I'm curious, what data do scientists still need, whether it's collected with SOFIA or other instruments, to give us a better idea of how we might collect and study water on the moon?
¿Qué otros instrumentos se precisan, o SOFIA, qué es lo que tiene que hacer para saber cómo podemos tomar esos recursos del agua, ¿no?
That it's going to be fairly difficult.
So I think that we have gotten a lot of great data from various remote sensing techniques, but I think that the next steps to really get at the big questions that we need answers to is to get down to the surface. With these CLIPS landers we've been talking about with Viper, and then of course with humans, that allows us to sort of see things at the centimeter and decimeter scale, where we can really get down and understand the distribution and location and the types of volatiles that we expect to be present there. And so I think that's sort of the next big evolution in our understanding of water. It's really going to require us to get down to the surface.
Great, thank you.
Yeah, and I can add to that real quick too, on top of what Sarah just said. You know, from an understanding how we access it, in addition to understanding the background of the water, the geochemistry of the water, we also need to understand whether or not it's affecting the geotechnical properties of the regolith it's mixed with. You know, is that surface harder? Is it more friable?
Bueno, tenemos a Sergio en línea.
And you know, how does that affect wheels, or how does it affect drills? So understanding physically what we're dealing with, that's going to be a critical piece of data. And just as Sarah said, you know, it really does require coupling these broad contextual observations from SOFIA, other orbital assets, with measurements right there on the surface. That will really help pull this together for us.
Great, thank you. Next, we have Ken Kramer from Space Up Close.
Hi, thank you for taking my question. For Casey, I'd like to know, can you talk a little bit more about, in detail, about your observations, follow-up observations of the moon, and when you will do them? Also like to know if this will be useful at other celestial bodies, like near-Earth asteroids, like Bennu. Would you be able to get any useful observations out of that? Thank you.
Está preguntando cuándo van a ser las próximas observaciones del sistema SOFIA.
Hours of observing time in the
Y si está involucrado también Venus.
current observing cycle for SOFIA. We expect to be doing observing in the spring of 2021, but those have yet to be scheduled. We have also proposed to SOFIA for an additional 72 hours to observe the moon. We would like to map the entire near side and also look at these volcanic features and central peaks that we think might be concentrating water. We have yet to hear back on if we have been granted that time, but we are crossing our fingers. We have also proposed to look at asteroids to look for the 6 micron water feature. We've requested over 6 hours to do that as well. So this SOFIA can definitely be used to look for water on other airless bodies.
Great, thank you. Great, thank you. I hope you get time. I hope you get time.
Thank you. Thank you.
Thank you. Next, we have Christopher from Sky News Canada again. Chris?
Yes, thank you. Can you hear me okay?
Yes.
Okay, always want to check. The previous question actually anticipates, and your answer, Casey, anticipates my question, which is, I'm fascinated that you said you wanted to map the entire near side and look at volcanic features and central peaks that might be concentrating water. So is there a suggestion in that statement that another mechanism for this water to be present at sunlit surfaces could be tectonic activity that's leading to outgassing?
It's likely not tectonic, but extinct volcanism that happened billions and millions of years ago. So
Estamos esperando un poco una idea un poquito más clara de todo lo que preguntan para después comentarlo con Sergio, ¿ok?
history of the moon, then it could have erupted the internal water onto the surface. And so we want to kind of see, by looking at these volcanic features, if that's true.
Okay, so you're looking at sort of primordial volcanism, not necessarily contemporary or relatively recent outgassing.
Yeah, that's correct.
Okay, great. Thank you so much.
Thank you. Next, we have Jim Siegel from NASA Tech.
Oh, thanks for taking my call. I'd like to hop on the back of Ken Kramer's question. It sounded to me as though, even though you have other ways of examining and evaluating how much water is on the moon and where it is and so on, with SOFIA and with the moon rover and so on, it sounded to me like there aren't any lakes or puddles of water. So I suspect that the initial Artemis flights are going to have to take their own water. And so that begs the question, well, if and when they do figure out how to mine the water from the moon's surface, would you estimate roughly how long it might take to really get that underway so that the astronauts don't have to bring their own water? For example, it's going to be 2026 or 2028, or would you hazard a guess about that? Thank you.
Yeah, I'll take that one. Again, it's hard to say a timeline for that because right at the moment we don't actually know which type of water we're going after, what the source of that water might be. We have to figure out if we're going to have a technology that's going into some of these cold places, or are we going to be developing the technology maybe that can extract the type of water that SOFIA is observing. Again, we have a cadence of payloads and missions coming up, especially working with the Science Mission Directorate and CLIPS to collect a lot of that information that will really help us narrow down what choices and pathways we need to take. You're absolutely correct. Artemis crewed missions will begin by bringing the water that they need, and we'll use that water. But one of the goals will be to continue to collect data that helps us understand what technology lines we need to follow to maybe one day be able to use the water that's there. In addition to that, you can also think about technologies that focus on recycling the water that you do have on the lunar surface. So, there's a number of ways for us to think about how to use the resources at the moon, take advantage of the resources we've already brought to the surface of the moon. And you know, I can't stress enough that we're really in the data collection phase right now to make informed decisions about the pathways that we want to follow for that.
Okay, thank you.
And that's all the time we have for today's Media Telecon. I'd like to thank the panelists and our operator for their time today. I'd like to ask panelists to stay on the line for a few minutes for post follow-up. If you joined this telecon late, you can listen to the recording.
Bueno, Sergio, a ver si te escuchamos. Vamos a ver si alguien nos puede confirmar si escuchan a Sergio. Aparentemente está saliendo. A ver. Habla de nuevo.
Hola, hola. ¿Me escuchan?
Yo te escucho claro, así que sí, empezamos como suponiendo que sí, ¿ok?
No, Lucas dice que no me escucha.
No se le escucha. Vamos a ver un poco. A ver. Jorge, Alberto tampoco. Yo te escucho claro. Vamos a tener que solucionar este problema técnico. Vamos a cambiar la forma en que accedemos. Quizá a través de Discord.
Ahí me escuché yo mismo después en el video.
Si tú te escuchaste en el video, entonces está saliendo. Sí, están confirmando que sí. Bueno, vamos del principio. La primera parte de esto, y lo más importante, es que con el sistema SOFIA, a nivel molecular, pudieron confirmar de que hay agua en la superficie de Marte, ¿correcto?
Así lo entendí yo también. Están usando este nuevo, no es nuevo, pero este aparato, telescopio en un avión, que así puede evitar la atmósfera y por lo tanto puede detectar infrarrojos, señales infrarrojas desde fuera de la atmósfera, en el espacio.
Sí, es importantísimo. Es un observatorio prácticamente espacial.
Claro, y el principal beneficio es que se puede ir arreglando y renovando constantemente, ya que tiene que aterrizar cada vez.
¿Qué significa esto de que haya agua a nivel molecular?
Siempre en el espacio es como complicado cuando uno dice hay agua, porque uno cuando dice hay agua uno se imagina que hay agua, digamos, para beber. Entonces ellos me imagino que intentan ser bastante específicos de que encontraron partículas de agua, pero que no es llegar y tomarlas, no es llegar y acceder a ellas, probablemente hay que procesarlas, pero es un primer paso.
Ellos dijeron respecto al tema cantidad de agua.
A ver, esa parte la verdad no la escuché, así que yo creo que tú nos podrías indicar mejor.
Ellos dijeron que lo que confirma SOFIA es que hay agua a nivel molecular. Dijeron de que SOFIA apuntaba a una latitud específica que no pueden confirmar en otros lugares, pero lo importante es que no solo hay agua en los cráteres, como ya sabían, sino que hay agua en otros lugares. Eso puede cambiar toda la exploración lunar, ¿no? Tienen que ver qué cantidad hay, dónde está exactamente y cómo pueden hacer para utilizar ese recurso.
Claro, el acceso es probablemente todo esto puesto en Artemis. Más fácil sería acceder potencialmente a esa agua. Y esa es la razón, yo creo, por la que se fueron a algo tan específico.
resumiendo, es terriblemente positivo esto, ¿no? Una de las cosas que hacían mucho hincapié es que justamente si encontramos agua en el destino, no tenemos que cargarla, no tenemos que reutilizar, o sí, pero no de gran manera para poder asegurarnos la continuidad de la vida, ¿no?
Para combustible. Por lo tanto, cada vez que encontramos agua, encontramos las bases necesarias para la expansión del ser humano en el sistema solar.
Bueno, vamos a cortar, Sergio, porque hay un tema doble eco, no lo podemos solucionar sin cortarte y sin cortar esto. Vamos. Perfecto. Buenísimo, buenísimo. Sergio, gracias por estar como siempre. Sergio Vidal es candidato a doctor en física espacial en la Universidad de Michigan, ¿no? Gracias, gracias por estar aquí. Seguimos en Discord. Hola. Bueno, cortamos a Sergio en este momento. Tuvimos mucho eco en la incorporación de Sergio Vidal en este vivo. La idea era poder entregarles un poco más, pero bueno, no nos salió del todo bien esa parte del vivo, del video en vivo de Sergio. Vamos a tratar de solucionarlos para las próximas. La transmisión de la NASA ya terminó. La confirmación, lo importante de esto fue la confirmación de que el Observatorio SOFIA, que es un observatorio astronómico de infrarrojo que va arriba de un avión, de un Jumbo 747 y va prácticamente en el límite con el espacio, le permite ver lo que no se ve desde Tierra. Y la ventaja de eso a un telescopio espacial es que pueden llegar a modificarlo fácilmente, porque cuando aterriza el avión se baja, se modifica ese telescopio a las necesidades y se vuelve a despegar para tener otra nueva visión. Lo importante también es que anunciaron de que van a seguir haciendo nuevas observaciones desde SOFIA. La observación que hicieron ahora fue en una latitud específica de la Luna. Lo que confirmaron es sí de que hay agua a nivel molecular en la superficie lunar, no solo como ya sabían en los cráteres, en las partes oscuras de la Luna, que es muy difícil acceder al recurso agua en esas condiciones porque primero la temperatura es terriblemente helada allí, entonces la cantidad de energía que tendrían que emplear para poder obtener el recurso sería tremendo. Quizás es más fácil llevarla que obtenerla. Entonces, esto puede cambiar totalmente las opciones y posibilidades que se generan para establecer una base lunar como piensan hacerlo a partir del año 2024 con la misión Artemis, ¿no? Bueno, gracias a todos los que se han sumado, gracias a los que soportaron un poco esto de que nosotros creíamos que la transmisión de la NASA iba a incluir por lo menos el video con los panelistas que estaban hablando y fue solamente audio. Las pocas imágenes que hay las hemos colocado nosotros, como esta que agrandamos ahora y que estamos viendo de lo que es el telescopio en una puerta del observatorio aerotransportado que tiene la NASA, ese Jumbo 747. Y bueno, recuerden, estamos en Discord aquí, de este lado. Estamos en Discord, súmense a nuestro servidor. Los que no lo vieron pueden ver, tocan en el canal y a la derecha del todo van a ver justamente el loguito que los lleva a nuestro servidor. Ahí tenemos chats, tenemos canales de audio, tenemos canales sobre ciencia, pueden escribir, pueden preguntar y podemos interactuar mucho más fácilmente de lo que es este canal. Los que no están suscritos, les recordamos, ahí tenemos el cartel de suscribirse, que lo vamos a agrandar un segundo. para que se vea bien claro. Ya somos una gran cantidad en esta comunidad de transmisiones espaciales y científicas que estamos generando. Gracias a todos por el aporte y el apoyo, ¿no? Gracias, Lucas, también por estar siempre ahí atento a moderar nuestro chat, de que siga la idea que tenemos de esto, que es charlar ordenadamente, con respeto, sobre qué sucede en el espacio y en todo lo que tiene que ver con la ciencia. Como siempre, muchas gracias a todos, gracias por estar ahí, nos vemos pronto. Estaba prevista para mañana el lanzamiento de Electrón, creo que quedó para el miércoles, lo vamos a actualizar apenas tengamos la confirmación de Rocket Lab, el lanzamiento de un cohete con 10 satélites y una cámara de Canon Electronics. Así que bueno, gracias a todos, nos vemos, un abrazo, chau chau.